Good afternoon, guys. Welcome to today's Thanks for watching our videos online. Please subscribe. Please do the press subscribe button and notification bell. That's our updates on this YouTube channel. Thank you and God bless you. Today I'm going to consider our 2023 life physics practical and what are the likely questions you have to meet in the aspect of methods. And this question based on the materials that Waec asks teachers to provide for the students. We can see that we have the ruler, the digital stopwatch or any stopwatch you are using, the knife edge, the reader stand, the basket of matches, and so on and so forth. Based on this apparatus that the Waec said they should provide for the students that are about to write the exam, we could discover that the relationship between these apparatus can be used to obtain the first constant of a helical string. Now, what do you mean by the first constant? This string has a force. Whenever you apply a weight on this string, it extends, and as a result of the extensions, there is a force constant. So the first thing is that they can actually test for this force constant K, and it can also be obtained from what? Firstly, it can be obtained from Hooke's law. Hooke's law can be obtained from Hooke's law, which is best suitable for this second possible questions. Hooke's law, which means that the angle, the mass, which is representing the force here. This mass is representing what? This force here is representing the mass, which is the load. Now, when we add the load, there is an extension, which is the extension is L2 minus L1. So extension is a result of increase in this in the length of the helical string as a result of the load, which is the mass, and on it. So the experiment can be used to depict Hooke's law, and as a result of that, you can get the force constant K from the Hooke's law. You can get the force constant K from the Hooke's law. So that was the way the experiment can come in this format. But because this one only involves the use of the load, which is the mass, and an helical string, and it does not involve It does not involve the time, and it does not involve the time. So that's why this second possibility is very, very low. It's very low. The chance of it coming out is very, very low, but it's a tendency for them to it's one of the questions that can bring out on that day. So I'm just introducing to it so as to know and to pay your mind. It's just this experiment, going back to the experiment, is very, very simple. Measure the initial length of this string before the weight is being added to it. So that will be the original length. And when you now handle the mass M, which is 50 gram or 100 gram here, what will be the new length of the string? Then you minus it from each other. You minus the original from the new length, and then you will get your extension E. Then here you will be your load, which is in gram, and then you convert it, divided by you divide it by 1,000 to get kilogram, multiply by 10 to take it to force. Then you can get your constant K from it. So you can also use this to get our constant K. You can also use this to get our constant K. So, and how do we go about it? We are still going to learn that in this lesson. And the first possible questions that relate and capture all the apparatus here is the relationship of T equal to 2 pi root 2 pi root M over K. Root pi over 2 pi root M over K. This is apparatus capture most of the apparatus here. And because it captures most of the apparatus here, we say this is the most probable question that you are likely to see on Tuesday. And the most important thing about this thing, So the important things about this thing is to know is that it can be easily manipulated without carrying out experiment. So far you know the what? The force constant of the what? So far you know the force constant, which is K. If you know the force constant of the string given to you, K, and you know the what? The weight of the ruler, the mass of the ruler, which is the what? Mass of the what? Ruler. If you know the mass of the ruler, then if you know the mass of the ruler, you can call it the mass of the ruler M what? MR. If you know the mass of the ruler, you know the what? The given mass of what? The mass is given. Mass of given set. MS. Mass of a given what? Mass of given set at a point in time, and then the what? The mass of which they ask us to label as what? The mass of the given set will be what? Will be what? Q. The mass of the given set will be Q. Please note that. It will be Q. This one will be what? Mass of the ruler R, which is same as what? Mass of the what? Of this is same as mass, which is the same thing as mass measured at the center of what? Gravity. Why this one is mass? Why this mass P is armed at the center of the gravity? Mass armed at center of what? Gravity. At center of gravity. At center of gravity G. At center G. So at center of gravity G, which is equal to what? Which is equal to 100 grams. This is given. This will be given to you. It's labeled at center G, which is labeled P. At center of G. Know that they hand it at center of G, and then it's will be labeled what? P. So NP will be what? Will be 100 grams. While NQ is going to be what? It depends on it. It starts from 20 according to this question. Then proceed to 40, 50, 70. It will be very low. So I don't want to ascribe any number to it now until we finish what? The practical. Now I don't ascribe a number. It changes as we continue the practical. So MQ. So this is going to be constant. MP, which is what? 100. And 100 gram will be armed on this point when you set up this practical. And then always again. So it is 100. That one is constant. This one will be vary. This one is the one that the reaction to be vary. And this mass of arrow is also what? Mass of ruler is also constant. You are going to derive it by the principle of what? Moment now. By your teacher. All these things, if your teacher gives you the constant K, the what? The mass of the ruler, then you are good to go to manipulate this what? This practical. So and that's why you have to be inquisitive, ask questions from your teacher, so that you'll be able to get all these things before even we start the practical, so that you have the minds of what you have to do in the what? In the exam. Now quickly I will quickly go to get my what? My mass of the ruler, so as to know how to manipulate this what? Experiment, and then we can go as fast as what? Possible. Now look at this. You have the what? You have the ruler here. And we want to measure the center of gravity for us, so as to be able to determine the weight of the ruler, the mass of the ruler itself. So you are not going to be doing this in the exam on that day. You are not going to calculate the mass of of the ruler, but you might have to measure the center of gravity. So this is just for the teachers that are in the house, and you should also know how to get the procedure, and how the procedure can also help you to get the vivid understanding of what is going to come out in the exam on Tuesday. Having this knowledge behind it, you'll be able to do very well with the practical. So now let me place this one. Let me see the center of gravity. So center of gravity here is, let's wait and see. Let's come back. Okay. Anyway, it means that that's not center of gravity. Let's try that point. So one of the precautions is that you avoid here or in interference. You can see we are now at the center of the gravity here, which is 49 point what 9 49 point what 49.9. let's take that is 49.7 49.7. So my center of gravity here is what? CG. Center of gravity here is what? 49.7 centimeter. 49.7 centimeter. So that's 49.7 centimeter. So I can now use this now to calculate my what? I can now use it to calculate my weight of the ruler. So you can just pick this one and then hang it on. Then hang it on the what? On any spot. This is 100 gram. This is a normal. So I just want to use the determine what? Place it on anywhere. I'm placing it on what? So I'm placing it anywhere. So you can also place 50 here. And it just use any mass, determine it. I'm trying to balance it up. Trying to shift this one. Just try and balance this. Look for the weight, the ruler can be balanced. Now, so we have the balance point here at what? 40 what? 2. It means that what? Look at this. This place is what I have here is my pivot. My pivot is resting on what? On 42, approximately what? 42. You have to look at it very well. But if I read from here, you have to know the point of where you are reading. If I read from here, what? I'm having what? 58. 0 from here, I'm having 58. So my pivot is at 58. So it's at 58 centimeter. So the mass here that I'm hanging here, you have to be precise about where you hang it. So here is around, reading from this spot is around 23.2. I'm having at 23. Let me see whether it can stand at 23 itself. So I have to have. But don't forget it is 23. So you still maintain that. You can see it's coming up. You still maintain that. So this is 23 centimeter, and this one is 87. This 23, 87. So 23, 87, we have what? So I'm having the 20 mass gram, the 50 mass gram at what? At 23. Mass at 23. Don't forget this is 0. So we have what? We have, let's see, this is what? This is 50 mass gram. And here I'm having what? 20 what? 3. Here on the other side I'm having what? 87. 87 centimeter. Please don't forget that this is 23. It's very important. This is what? This is 87 centimeter. So how do we get the weight of the man? Don't forget that our center of gravity here we get 49.7 centimeter. So which is the what? Which is the mass what? M, the weight of the ruler. MR. It's very important to get the weight of the ruler. MR. So we have the MR here. We have the MR here. So which I want to determine using this principle now. So we have what? we have principle of movement, which is movement around this pivot. So now the mass hand of the cell is what? Is the mass hand of the what of itself. The mass hand on itself is 100 grams. Is labeled there is what? Is 100 grams. So I have to be sure of that. 100 grams. The mass hand on this is what? 50 grams. So with this now, we can now say, okay, the distance from the pivot to this is what? 87 minus what? 87 minus 58. 87 minus 58, we have 29 centimeter. 29 centimeter. And then the mass, the distance from here to here, the distance of MR to the pivot, distance from MR to the pivot is what? Is actually 58 minus what? 49.7, which is what? 8.3. This one is 8.3 centimeter. So the distance between the pivot and the what? And the point of MR now. So 58 minus what? That is 8.3 centimeter. Why the distance between here to the pivot is from here to this point. From here to this point. Please look at it. So 23, that's 58 minus what? 58 minus 23. 58 minus 23. You have 35 centimeter. So I'm trying to let you know that is the distance from here to here is what? 35 centimeter. From here to here is 29 centimeter, and so on and so on. To use the principle of movement, which says anti-clockwise what? Clockwise movement equals to anti-clockwise movement. So this clockwise movement is anti-clockwise movement. So we are going to add this one together and equate it to this. So 50 times what? Don't forget this is in grams. So whatever we are going to get is going to be in grams. 50 grams times what? Times the distance between here to here is what? 35 centimeter. 35 centimeter. Then plus MR times what? 8.3 equal to 100 grams. 100 grams times 29 centimeter. So 29 what? Centimeter. So 29 centimeter. So we now have what? 50 times 35. We have 1,750 plus what? 8.3 MR equal to what? 100 times 29 is 29,000. So that 2,900. So we take this one to the other side. Take this one to the other side. So I hope you are following. So with this now, it said what? 2,900 minus 1,750. We have 115. We have 1,008.3 MR equal to what? 1,150. So the value is 8.3. 8.3. So the mass of metal relay that I get here. So MR now, for as far as this ruler is concerned, the MR here is 138 gram. 138.55 gram to this one is. So according to this one, this is 138.55 gram. You can see how I calculate my what? My mass of what? Of ruler 138.5 gram, depending on the ruler you are using in your what? In your school. So this is what? 138.55 gram. You can say I get 50 times. This start from here to here is what? 50. That's 85, 35. Then 11 times is 8.3. then 29 times 100, which is 2000. So when I transfer this one to the other side, I will also have differently. So my mass of what? Ruler here is 138 point what? 138.55 gram. So that's the mass of my ruler. So I've known the mass of my ruler, I've known the mass of what? Of P. Then this one now, I cannot get my what? Force constant. Let me get my what? My force constant now. So you can see it remains like that. It means that it's balanced at that point. So let me quickly do that one now. So this one now, you can get your force constant in two ways. In two ways, you can use what? The principle of what? Hooke's law. You can actually measure the what? The length of this, and then know the length, and then after knowing the length, then add the mass, and then look at the what. But since we are using the what? The time, we are calculating the time of the what? Since we are using this one, we are using this principle. It's better we use what? This to find our force what? Constant. We can actually use this one by measuring the what? The original length of the what? Of the original length of the string you are using. Look at this. You can decide to use what? The meter to measure it. This about. This is. So this is 11.5. 11.5. Now consider adding what? 11. That's the original what? Length of the what? Of this spring. Of the spring itself. So if you now have like 100 now to it, what will be the what? The new. So there will not be much difference anyway. So that's why this is okay. We are having 12.5. We are having 12.12. 12.5. Everyone is 12.5. So meaning that the difference here is just 1.0 centimeter. So now with your mass of the what you are handling now, which is what? 50 gram. With the mass of thing you are angry now, you can actually convert it to meter. But I don't want to use this rule. That's what I'm just trying to say. You can use this one. This one, especially here, is just equal to 12.5 minus what? 1.5, which is what? Which is E equal to what? 11.5 rather. So E here is equal to what? Is going to give you what? 1.0 centimeter. So you can take it this one to the meter. So if you take it to meter, it's going to give you, divided by 100, it's going to give you 0.01 meter. Essentially, it's going to be what? A meter. That's 0.01 meter. Now, with what? With that, you can now, and the mass we are handling here is what? Is 100 what? Gram. If I'm going to use that one, I'm trying to tell you that if I'm going to use force over KE, the mass here is going to be what? 500 or 100 gram. So if we divide that by what? Into kilograms. If we take down force, that mass, no, we are using this one, we are using Hooke's law. We are going to use what? Extension is equal to 0.01 meter. Then your mass will be equal to 100 gram divided by 1000. You have 0.1 gram. 0.1 gram. Then take it kilogram rather, kilogram, because I'm dividing by 1000 because I'm going to take it for kilogram. Then we have force equal to M what? G, which is equal to 0.1 times what? 10, which is what? Which is also what? Which is also 1 Newton. So if you are going to be using this one now, you can see that your force constant will be equal to this force, which is 1 over Newton. 1 Newton all over 0.01. 1 divided by 0.01. So meaning that this is what? 1 divided by 0.01. 1 divided by 0.01. So that's 100. But I don't want to use that because actually we are not detecting the word extension. We are looking into what? We are looking into the time. So I'll just tell you that if this one is what comes out, if this one is what comes out, it means that what? Your first constant here will be what? Will be 100, or it will be 100 Newton per meter. But we are not using this. I'm not using this one for the word because we are not looking into what extensions and what and so on and so forth. We are not looking into what extensions and we are not looking into what load and extension. So we are looking into what into the time and the mass in relation to what to the constant. So that's why I'm going to use the oscillation method of calculating what or calculating the first constant. And how do you go about that? You hang your what? Your string back again, hang your string back again, add your string back again, and then you add your 100 gram of mass. Please take note of that. I'm going to count this along using first extension, but you can keep that one in mind. So now I'm going to do this one. I'm going to use the stopwatch to look for my period. Then after I will calculate my first constant from here. So we have what? This is my digital stopwatch. Now I will just tap this. I will tap it, then I will start my old stopwatch. So 1, 2, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is what? 0.15. 0.15. So your t here, your small t, please note that I want to calculate what? The first constant now. You can calculate this twice so as to know when you can do it so as to know exactly what is your time. You can still do it to check once again. So you tap this, you reset your stopwatch. This reset, you stop, then you reset. So and then you tap this again. Make sure you reset. Then let's start again. This by time is I've not yet, but okay, reset. You have to know how to undo it very well. So that's the essence of practice. Now it's in 0 now. Then let me what? Tap this again. It has not started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you can see this is what? This is 14. So it's the same thing as what? We have what? T1 is what? T1 I get 60 and T2 I get what? 14. So I can easily calculate my T to be T1 plus T2 divided by 2, which is 16 plus 14 divided by 2, which is 15 seconds. So my T, because I'm calculating 20 oscillation, my T will be what? 15 all over what? 15 all over n, which is 20 oscillation. Don't forget that T is equal to T over what? N, which is 15 over 20. So 15 over 20, 15 over 20, 15 divided by 20 is equal to 0.75 seconds. That is my period. Now, with that, I can easily calculate my K. If you make this one subject of the formula, if you make this one subject of the formula, you just square this into what? T squared all over 2 pi. T squared, you square everything, T squared over what? 2 pi equal to. Then after you have squared this, taking this one to the other side, then you try and make what? So we are going to have m over what? K. We are trying to make K sort of formula. K will now be equal to m all over. Okay, K is going to be what? Making this with 2 pi m all over T squared. So that's your K. That's how you're going to calculate your K. Just put 2 times pi times m all over T squared that you just get. This is your T. Don't forget this is your T now. So I'm just going to press this calculator so as to write my K here. It's very, very important so you know your K is here. So what's your K? Your K is now going to be what? Your K is now going to be 2 times 3.1 pi times your mass. Your mass is 100 gram. If you take 100 gram to kilogram, 100 divided by 1000 is 0.1. 0.1. Now 0.1, I'm having 0.1. So this is 0, my mass is 0.1 because I take it to kilogram. Don't forget I'm going to convert it to kilogram so as to have SI unit of K. So to be in what? In standard form, not in other units. So 2 times 5 times 0.1, which is what? Which is the what? The mass of this in kilogram. So divided by 1000 is 0.1 all over T squared. What is T squared? 0.75. T squared is 0.75 all squared. Don't forget I'm using this formula. Follow this formula comes here. So I make K of formula, I square both sides. If I square both sides, what's the what? If you square both sides, this not that. If you square both sides, this part also will carry square. So this one is going to carry square. So it's going to be what? 4. So you square both sides to eliminate what? Square both sides to eliminate the what? The root. So T squared all over what? All over 2 squared, because when you square this one, it's also carrying T squared over 2 squared pi squared equal to m over what? Over K. So this root has cancelled square. So now we now have what? The formula now is now what? 2 raised by 2, which is equal to 4 pi squared times 0.1 all over 0.72. So what do you get as your K? This follow. So please note that I believe you understand this very well. So I've made mine. So 4 times pi shift pi all square times 0.1. That was not carry square 1 divided by 0.75 all square. So my K here is 7.01. So this one is 0.18. 0.183. So that's my first constant from making this sort of formula. Don't forget, I square this one. I square this one. That's T squared. I square all everything here to become 4 T squared m over K. Then you cross multiply. When you cross multiply, you have TK. Then you have 2 pi m TK. You divide both sides by what? T. Which happen here, which is squared, which is having 2 pi m over T squared. So the formula for K is 2 pi m over T squared. So what I substitute here, which is what? 4 pi squared times the mass in kilogram. Mass of what I use is 100. So this 100 gram. So don't mistakenly go and use this 100 gram. So this 100 grams I divide it by 1000 to get 0.1. So 4 times r square times 0.1 all over 0.75 square. I get 7.0183. That's the first constant. The unit of first constant is divided Newton per meter. Newton per meter. So that's that, Newton per meter. So now with this now, nobody will ask you to calculate all these things in the exam. I'm just trying to tell you that we can actually manipulate our time from what we are here. So now, the table asks us to look for what? For the mass T1, T2, T, and T equal to T over N, then T squared. So now, meaning that now we know this theoretically now, and we cannot use it to calculate time. But let me teach how you can use it to calculate what? Time. So I will know this one to be what? K to be 7.0183 Newton per meter square, depending on the unit anyway. So if you use that of first constant, it's going to be 12 Newton per meter. So now we have what? We have your mass now. MR, the mass of the roller, is 38.55 gram. The mass of Q, which I said is going to be very. If this one is 20 centimeter, if this one is angle, if the first one is 20 gram, as said we should label, the first one that we are going to label is going to be 20 gram. So let's say that the MQ1 is 20 gram, and then the mass of the P itself, I gave here, which is 100 gram. Or then I will add them together. The total mass that will be acting here will be MR plus what? MQ1 plus what? MP. What do we have? So we have 20 plus MQ1. What's MQ1 here? We have MQ1 is what? MQ1 is 20. The MR is 138.55 plus 100 equal to 258. This one is 258. 258.55 watt gram. So taking this one to 1 kilogram now, the other one has to be 0.25855 kilowatt gram. So the other one has now we now say we cannot get our T now using this formula. T is equal to 2 pi root what? M over K. Let's try what we're going to get first. So we're going to have what? Your mass is 0.258855 divided by what? For the T1, divided by 0.0183. Square root this 0.25855 divided by 7.01883. So your teeth here times what? Now the other one, then don't forget the 2 pi. There is 2 pi outside. So multiply by 2 pi. So I'm having for my T1 here is going to be what? 1.2059. My T1 here, please follow. My T1 here is going to be what? 1.0259 to 4 decimal place. Now I can easily say, okay, my T here, since I know that my T here Since I know that my T here is the addition of, okay, I know that my T here is addition of these two AB, and then this one, T is equal to T all over 20. My M here is 20. So I've got 1.0 equal to what? T over 20. So multiply this by 20 oscillations. So my first time that I'm going to get is 24.1. If you multiply this on T times 1.0258 times oscillation. Please look at this, please. I'm trying to let you know. So your T1 here, your T1 is 1.2059 equal to what? T1 all over what? 20. Just cross multiply using the principle of mathematics. Cross multiply. You are going to multiply 20 times this. You are going to get 24 seconds here. So meaning that our time here is 24 seconds. 0.119. Now, this one I want to leave it as 1 is because your digital stopwatch is going to be in 2 words. It's going to be in 2 decimal words. It's going to be in 2 decimal places. So, if we are using digital stopwatch, it's going to be in 2 decimal places. If we are using analog words, stopwatch, it's going to be in 1 decimal place. So, I'm using digital stopwatch. I'm going to take this time to go 24.11 seconds. So, I've already done this T1 like this. This is my T1. I can also repeat this process for T2. Then, for my T2, let me clean this one. And since I have known this one, please note this. Before I do it to practical now, my T1 is 24 seconds, 1. So, you can just repeat this process. If you don't want to disturb yourself, this one is just 24.11, 24.11. So, I don't want to disturb myself, so 24.11, 24, and divide by 2, you see how what? Because T1 and T2 divide by what? 2, you give me this one. So let me write it out. T is going to be T1 plus T1 plus T2 divided by 2. So because you want to have 24.11, just repeat the same thing here. And then this one is going to be your 20 what? Your 20 gram. It's going to be your 20 gram. So this is going to be your 20 gram. So with this now, T square. Now our T square, we've calculated it from this, which is what our T square is our T is 1.2059. So you can easily calculate your what? Your T square here, which is what? 1.2059 squared. So I will have what? 1.4541 to 4 decimal place. So you can extend it to that for, you can also add 0 to make it uniform. So you can extend this one from 20.000 to 2 decimal place, this one 2 decimal place, this one 4 decimal place, and then you can approximate what later. So that's that about that if you want to manipulate this. Now if I want to calculate the rest of the T2, T3 and so on and so forth, let me do it now so as to know how I come about this. It's very, very important. So now let me clean this one since I've written all the value words here. Don't forget our first constant is 7.0183 Newton meter squared. Our M1 is what? 138.55 gram. Our MQ2, we are going to do for MQ2 now. So, and that's what MP is what? 100. Now I'm going to clean this so as to be able to do the rest. Let me check the video whether it's doing very well. Okay. So now I've calculated before the second one, which is the what? We are asked to what? To add, repeat this procedure of addition of 40 gram, 50 gram, 70 gram. So now this one for 40 gram. For 40 gram, which is what? For S2, serial number 2. Serial number 2, our mass of Q will what? Add another 20, another what? Make it 40 gram. That is, by adding 20 gram to it, they will ask to add what? 20 to it to make it 40. Are we together? you can ask you to add what? Add 40 to it. Add what? But this one says you should add 40 to it. Meaning that what? We have 20 before, then plus 40. We are going to have what? 20 plus what? 40. So that's why I'm going to do it. But if they say you should add 20 to it, so let's first consider that 20. Or let's say this is 40 now. So when it is 40, meaning that this one is 20 before, or they might have told us the value of 20, then you add 40 to it. Are you getting what I'm trying to say? But now I will assume that this is 40, our MQ now is going to be total equal to 40, including this one. So please note that I will assume this one is just 40 grams. Our MQ, total MQ is what? 40 grams. I will not add with 20 and say initially. So I'm taking it as what? 40 grams now. Do you get that? So even though when I say add 20 to it, so making 40. So I'm taking total MQ now at this junction to be 40 now. Do you get that? So I hope you get that. So 40 grams. So this one is now 40 grams. And then we know that our MR, for that is the mass of metal that we just did together, is 138.55 grams. 0.55 grams. Then we know that our MP is 100 grams. I'm writing it out so I should see how to do the other one as we proceed. So this is 100 grams. So what is our constant? K is 7.0183 Newton per meter square. So that's our first constant. So we can now still use this method and now don't go about that. So we find the total mass M. The total mass M, which is MR plus MQ plus then this one as MQ2. So as not to confuse ourselves. So MQ2 plus MP, which is MR, which was MR. MR is 138.55 plus MQ2, what is your MQ2? 40 plus what? MP, what's your MP? 100. So if I add them together, what do you get? 138.55 plus 40 plus 100. So we have 200, so MR equals 278.55 grams. Divided by 1000, take it to kilograms. It's going to be what? 0.27855 kilograms. Just write like that. You have to be main. You have to what? You have no approximate, you have to retain the value like that. So that is in kilograms. So you now come here and say, okay, then our T is equal to 2 pi root what? Root K over G. Okay, root what? M all over what? G. So 2 pi, just use your calculator, so calculator take that pi. Then root what? What's your M? M this time around is 278 pounds. Sorry, in kilogram now, 0.27855 all over what? All over, sorry, don't forget this is K, I'm not using G. All over K, 7.0183. So T is now equal to 2 pi. 2 pi. Okay, shift. You can just press shift. You can write 2, then you press shift what? There's a pi here. Pi. Then multiply by root what? Then 0.27855 divided by 7.0183. 7183, please do that. So if I do this, what do I get? I get 1.2517 1.2517 1.2517. Don't approximate this one like that. I have to write to put a smart place here, but I'm going to use the one calculator to get my what? T now. Don't forget my T here is going to what? My T here is going to what? The period here, this period, this is T all over N, which is 20 oscillation. So to get my T, now I cross multiply, which is T equal to what? My period 1.2517 times 20. So this one times 20 now. So I have 25. So this place is 25.03 seconds. So this one is 30. So you can see the difference is 1. So this one is 25 seconds. So I can easily say, okay, 25.03 for T1 and T2. If you want to, nobody will penalize you for that. So this is 40 what? Gram, 40 gram. So the next one is going to be what? 50 gram. Please put it to 2 decimal place. For this one, 2 decimal place. So there's no need for me to repeat what. This is what? 60 gram. So what? And then, so this one should be 70 what? 70 gram. And this one is 80 gram. So with that now, you can now easily calculate your what? Your T square from here. Your T square, you can easily calculate T square from here. That is 1.2517 or square. So you can square it. So I'll give you 1.566 cell. So after I get it, so we do it for the next one for T3. So for T3, you use the same method, but this time around for S3, your T3, how do you get that? Your MQ3 is going to be 50 because we are given 50 here. Your MR is still what? 138.55 gram. Then you know that MP is constant, 100 gram. So 100 grams. So with this now, we can actually now get our total, which is M equal to, add this one together, 50 plus 138.55 plus 100. Sorry. So 50 plus 138.55 plus 100. So this is 288.55 grams. Divided by 1000 is going to be 0.28855 kilogram. So with this now, I'm doing the third one, which is serial number 3. That's why I call it S3. So S3. So now, with that now, you can now use our formula again. Don't forget our K is 0.018. So that's the value you need to cram when you are going to the what? To the exam. This K, you must know it. If you want to, you must even have aligned the value you want to use. You just do as if we are doing practical, you do 1 and 2, then you want to write the value, you plot your graph without wasting much of your time. So K is equal to 7.0183 Newton per meter. Then you can now say T now equal to 2 pi root M over K, which is equal to 2 pi times root what? What is your M? Your M sign is 0.28855 divided by 7.0183. So the same thing you have to do here. So 2 pi sheet pi times square root. So this is 0.28855 divided by 7.0183. So This is 1.27. This is 1.2740. 1.2740. So now you can actually get your t square if you want to do it like that. Get your t square, but for us concerned about the t first. So t is equal to, according to this formula now, so t will be equal to what? 20 times capital plus multiplying. So which is that 20 here, this one times 20, but t is 25.48. 25.48. 25.48. So your t is 25.48. So seconds. So this one is also in seconds. So now 25.58, you can also put 25.548 here. 25.48. There's no time to waste time. So now, so the next one is what? Is this. So let's do the other two values, then we'll plot the graph. So the other two values, which is 70. Let's do the other two values, which is your MQ now is now what? MQ4 is now 70. The reason I'm doing this one is I want to make sure that we finalize this together. M is 138.55. So this one is 70 now. So M is equal to 70 plus 100 plus 138.55. So we have 308.55 gram equal to now 0.30855 kilowatt gram. So your T now will 2 pi root what? Root N over K, which is equal to 2 pi times 3.0855, 0.30855 all over. Now it's just K is 7.0183. So T is equal to now 2 shift pi root what? Root 0.30855 or 0.0183. So what will that one give you now? That one will give you T is 1.3174. So multiply this by 20 to get 20 times T to get your what? T3. T4. So times 20. This is 26.34. 26.34. 26.34. You know we are using 70, so everything is 26.34 here. So this one is 1.3174. So you can square this one. I forgot to square this one. 1.2740 squared. 1.6230. This one will be 1.3174 squared. For T squared, I'm talking about T squared, is 17355. So now, with that, now we can do the last one, which is for T5. Talk about what T4 here. So M5 now. MQ5 will be equal to 80. Then MP is what? 100 gram. Nobody is expected you to write all this in your words inside your answer script. So you have to do this roughly, then know the value or know how to get it in the exam to save your time. M result 138.55 gram or 55 gram. So with that now, adding together, M is equal to 80 80 plus 100 plus 138.55 divided by 1000. Yeah, 0.31855 kilogram for the what? Mass. Then your T is now 2 pi root what? M over what K, which is square root of M. What is M? 138.5. Okay, in kilogram now 0.31855 all over K. Don't forget there is 2 pi. 1 over K 7.01883. Can you see I've already crammed it? So that's how it goes. The more you use it, the more you get used to the constant. 7.0183. So my time here is times 2 pi shift time 1.33. That's my time. 1.3386. 1.3386 is 1.33886. So seconds, then your T is equal to 20 times T, right? So times T, just use the value like that, times what? You have 26.772. So we have 26 here. 26.77777. So that's that about that. So we have successfully calculated what the value. So you can actually now get what this one now by squaring it. So 1.33, you can get to square 1.33865, then square, or 1.3386 square. So I get 1.7918. So these are my value for the what? For the manipulations. You can still take over. Now if I carry out the practical, I'm still going to get the same thing. So let's just do one so as to get. So if I have to do this one practically without using the manipulation, you have to what? You have to balance this thing, place your what? Your string here. Let's look at this. At what? 10 centimeters. So I'm going to place my 10 centimeter mark. I want to place my ruler at 10 centimeter and my string at 10 centimeter. Then place my P, which is what? For the first time, it's going to be 20 what? 20 grams. So what is my 20? So now I'm folding this one twice to make it tighten. So I've done before. I thought of using it once. So this one at 20 centimeters, so let it be at 20 centimeters. So now this one is going to be at what? While the other one will be at what? At which is the what? At center of gravity, that is P. My P is 100. Take this one to 100, right? It's going to be at the center of gravity. What's my center of gravity? Don't forget, my center of gravity is 49.7 centimeters. 49.7 centimeters. That's what I get for center of gravity. If you rewind the video, you'll see there 49.7. That's what I got. So I'm going to put this one, measuring it from this side. I take my reading from this side, not from this side. So you have to be careful of where you are putting it. So and I'm using this side this time around, so I'm going to put it at 49.7. 49.7. So this 49.7, so this one is going to be at what? At what, 20, and the other one will be at 10. So at 10, so will be at 10. You can actually adjust the what? This will be at 10 so that it should be tightened up. I will adjust it later, but let me fix this one first. Then this one will be at 10 centimeter mark. At 10 centimeters, this one is going to be at what? At 10 centimeters. So you can see this is how the setup will look like that day. It's at 10 centimeters. So then we are asked on what? 20 grams here to be our P. So 20 grams. So I'm going to use this one as my 20 grams and earn it at what? So that's how the setups looks like. So make sure that they are vertically what? So let me check. Yeah. So that's how it looks like. So this one is at 10 centimeters. So what we are going to do now is now take out the stopwatch, set it to 0. Set it to what? 0. Set it to what? Let's stop it and let's reset. I have to know how to use it very well. Okay, this is at 0 now. Then I will displace this one. You can see the oscillation that is occurring. This is what we call it. There will be an oscillation, downward movement, to and fro. So let me tap this now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is 24.12, which is very close to 24.12. It's very close to 24.11. Do you get it now? This is 24.12, but this is very close to us. Which is very close to 24.11 that we did during manipulation. So that's how it works. That's how it works. So let's quickly plot the graph now. Now here is our graph graph banner. Now I've written out the table value obtained from the for our readings. So now this is This is the t-square and m. We are asked to plot a graph of t-square on the vertical axis and m on the horizontal axis. So the first thing is to write the title of the graph. Graph of t-square, which is period square in second square, against m in gram. So that is the first thing. Now the second thing is look at your value. Now we have 1.45 on the vertical axis, 1.5, 1.6, 1.7, 1.79. Now look at this time. If I want to actually do this now, if I choose 0.2, will I be able to get to 7? 1.7. If I choose 0.2, let me say this is where my graph will be because of the extension to the. I don't want it to get to the bottom here because of so I can see it. So let's see if I have from here from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I already have 12 centimeter, 12 2 centimeter boxes, 12 2 centimeter boxes. So if I use 0.2, I will get 2.4. So 0.2 times 2.4 is going to 0.2 times 12. It's going to give me 2.4. So I can easily use that. I can easily use 0.2. I can easily use 0.2. What I mean is that if I use 12 2 centimeter box that I have here, and I use 0.2 with that box that I have here, I'm going to get the highest value of 2.4, which is quite okay. So if I say I use 0.1, I will not get 1.79. So I will use what? I will use 0.2. Now what do I mean by that? My scale will be 2 centimeter represent 0.2. 0.2 on 0.2 square, s square, 0.2 s square, that's 0.2 second square on period square axis, because the vertical axis is now period square axis. Then on the horizontal axis, I'm going to 80, right? I can use 10, 10, 10, 20, 30, 40, 50, 60, 70, 80. So that's what I can use here. If I say I use 5, it will get to 80. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how I use what? 5. Let me use 10. 2 centimeter represent, so that you get 100, represent 10. What's the unit? 10 gram. 10 gram. 10 gram. 10 gram. You can just write 10 gram. There's no need for you to put out 10 gram on M axis. That's your scale. That's how you choose scale. That's how you choose scale. So that's that about that. So now let's quickly plot. Don't forget, we're starting with what? A. Or you can even put it up if you want to, because you are going to have more than enough. So let's start there. So that will be our 0,0. So I'm drawing a line first, the vertical line, which is our t square. So now the horizontal line. So we have 0,0. Now, I haven't drawn this one now. We know that this place will be what? 2 centimeters or 10 gram. 10, 20, 30, 40, 50, 60, 70, 80, 90. So this is mass in what? In gram. Then from here now we have 2 centimeters to 0.2. So this one is going to be 0.2, 0.4, 0.6, 0.8, 1.0. 1.0, so 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 1. Then 2.0, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0. So that's that about that. So I haven't chosen the scale now. Now let's plot the what? The graph. Now look at this. We have 4 decimal places there. We can easily do it to 1 decimal place or 2 decimal places. But because I can actually approximate it to 1 decimal place and I can still get the point here. If I approximate it to 2 decimal places, what I mean by that, if I approximate it to 1.45, I can still locate it on this graph. So it's better I approximate to what? 2 decimal places, which is 1.45, than to approximate it to 1.4. It is more accurate when you approximate to what? To high number of what? Decimal places. So 1.45, I'm going to be plotting 1.45 against 1.57. That is approximately this one. This one will be 1.62. Then 1.7. The last one is now with 1.8. So that was what this is going to be 1.74. So it's going to be 1.79 to 2 decimal place, don't forget. So 1.79, 1.74, 1.62, 1.57, 1.45. So 1.45 against 20. Now this is 20 here, 1.45. This is 1, 1.2, 1.4, 1.45. We know this one is 0.2, right? 0.2 divided by 10. 0.2 divided by 10 will give you what? 0.02. Meaning that what? Each multiple box here represents what? 0.02. So if I get this one is 0.0, this one will be 1.42, 1.44, 1.46. So this is 1.46. In between 1.46 and 1.44, there will be 1.45. Against what? Against 20. So 20 against 1.45. This is 1.4 to 1.44, 1.45. This is 1.4 for 1.45. This is 1.45 against 20. Don't forget 10, 20. So 20. Let's be fast. Now, next one is 40 against 1.57. 40 against 1.57. 40 against 1.57. 1.57 is, this is 1.5 here. 1.5 here. So 1.52, 54, 56, 58, 57 will be in between here. So against 40. So this one will be here. 1.57. 1.57. Then the next one is what? 1.62. 1.62. 1.62 is here. Then against what? 50. 50 is here against 1.62. This 1.6, 1.62 here. 1.6, 1.62. This is 1.6, 1.62 against 50. Now we have 70 against 1.74. 70 against 1.74. This 70 against 1.74. This 1.7. Then 1.74. 1.7, 1.7, 1.7 to 1.74. 1.74. Don't forget this 1.74. So against what? 70. So we have it here. And last one is 80 against 1.79. 1 is 1.8 is this line. 1.8 is this line. This is 1.8. Now 1.8. This one is 1.8. This is 1.8. Then 1.79. This is 1.78. 1.79 will be in between. It will be in between. So 1.79 is going to be in between 1.78 and 1.8 itself. So that's that about that. So you can see 20 against 1.45. 40 against what? Against 1.57. This one against what? 1.62 against 50. And so on and so forth. 1.74 against what? 70. And so on and so forth. Now let's draw what? The slope. Let's draw the gradient itself. So we have, we look at it very well. Does it take? Oh, it takes almost every of the what? Points. It's not actually take everything what? It actually pass through everything. That shows that our point is reliable. So now, that's that. That's one of the advantages of what? Of using the manipulation method. So this is point here. We use this point here to choose my okay, let me use this. Sure, let me. So this is. So you draw a right angle here. Okay. So this is right angle. Let me check the camera. So now, so you can see that what the point is still here intact. We have it here. We have it what here. So now we have our ball. So these are the 5 points that we have. Now let's now pick the slope points. So okay. So now I'm picking this one. Picking it down here. So this one down here. So now we have the M1 and then we have the with M2 here. So if they ask to calculate intercept, this will be your intercept C. So now let's choose this side too. How to place it very well. Okay, so and this is the other one here. So this one is what? T2 square and T1 square. So our slope will just be change x is equal to change in T square over what? Change in M, so which is T2 square minus T1 square over M2 minus M1, which is equal to, now T2 square is 1.8284, 1.8284. So that is 1.82 is 1.84. That's what I mean by that. 1.84 minus 1.84 against 1.40 centimeters. Okay, period is in x squared. Now, this one is 11, 12. Because this is 11, 12. And this one is 79. 79. Okay, this one is 89. This one is 85, 86, 88, 89. So 89 minus 12, 89 minus 12, 89 minus 12 in gram. So let's quickly do the calculation. So we have 1.82 minus 1.40 divided by, I'm doing it once and for all, 9 minus 12. This one will be 3. It will be 3 points. It will be equal to 5.454 times 10 raised to power minus 3 seconds, or you can write per gram 10 seconds squared. So I don't want to mix up with this, so I can write it here. Gram per gram. This gram will go up, then per gram, then seconds or square. Per gram is per gram second square. So that's the unit. So that's that. You can take this one by one, then if you then take it one by one, then you write your final answer. So that's that about that. So we have come to the end of today's practical. So another thing we can ask you is what the intercept. The intercept is where it touches this one. This is approximately what? That is 1 point. This 1.3, 1.32, 1.33, 1.33 x squared. Because this is what is along the vertical axis. So 1.33. So that's that about that. So the precaution is that I avoided air interference when trying to balance my meter rule. That's the first thing. Number 2 is that I also avoided error due to parallax taken on the meter rule. I also ensured that the masses are well tightly I hang tightly on on the string on the meter rule. I also avoided zero error on my stopwatch. So thank you for watching. We're expecting the electricity very, very soon.